Hello, everyone. I am sorry that I have to be gone today, but show must go on. So we're going to stick with our current plan, which would be today making our review sheet for our Chapter 2 test, which will be next Tuesday. So today we'll make the review sheet. Next day in class, we will be completing the practice test, and then the following day we will be taking the test. So that's the current plan. You need to start by having out a piece of paper and then dividing the piece of paper into 3 sections on front and back. There are 6 sections that we'll put on our review sheet. I believe 5 of them I think will be filled in, and 1 of them will be blank for you to use to put extra examples. Yesterday we took our quiz in class, and I'll have those quizzes back to you when I return the next day. They should be graded in PowerSchool already for you to check. So have a piece of paper out, divide the piece of paper into 3 sections on front and back. If we need to pause the video until everyone's ready, then go ahead and do so. Otherwise, I'm going to assume now that we are good to go forward. So at the very top of that first section, right up here, I would title that first section 2.1, Writing and Graphing Inequalities. Writing and Graphing Inequalities. That's where we started. This whole chapter is on solving inequalities. Inequalities meaning not equal to statements. We've got one side less than or greater than the other side. If you look at the back of chapter 2 in the book, so at the very end of it, they do a review section. That's where I pull these examples out for us to look from. If you want to look in that section, you'll see them for yourself. Otherwise, I'm just going to talk through the ones that you should be writing down. So the ones down here, as I write, you should be writing these down with me, in this section for the first section. So the first one would be an example of translating. We should be able to translate the statement, the difference of twice a number x and 7 is at least 20. Let's start with the difference. Difference means subtraction. So I know there's going to be a subtraction. What am I subtracting? I'm subtracting twice a number x, so 2x, and 7. So I have 2x minus 7. Then they say is at least. At least. If I tell you you need to make at least $30 running a lemonade stand, that'd be 30 or more. So at least means greater than or equal to, and the last part is the number 20. And there would be our answer. So the answer is 2x minus 7 is greater than or equal to 20. That's what the translation would look like. So we started this chapter by just translating from English to math. Then we started to graph inequality statements. If you have an arrow pointing to the left, that means less than. Because numbers as you head to the left on your number line, get less than or smaller, less positive. As you head to the right, that means greater than. So you should write that down, have a little key for yourself. Even if you think you know it right now, it's helpful to leave yourself a safety net. And then as an example, can we graph my x's, my values, my solutions are less than or equal to -2. So you draw a number line, put down -2 as the key point. I'm going to put a circle around -2. I want all the values that are less than. Those are all of the values to the left of -2. Draw an arrow saying that I could keep continuing on, going to the left. Well, screen's frozen. Well, that'll give you just a second to continue writing. Give me a second to try to unfreeze it. I think we should be good. Yeah, we're good. Okay, arrow pointing to the left as we shade in. Last part, it says I need to be less than or equal to -2, so I would fill in the -2. If I pick any number that is equal to -2 or less, I will have a true statement. Let's try. Pick a number less than -2. You could pick -3, you could pick -5, you could pick -1,000, you could pick -2.1. All of those would work. Let's just pick, I don't know, -4 maybe. Oh, my screen's not working. So -4. If I pick -4 and substitute it in, -4 is less than or equal to -2. Is that a true statement? Indeed, it is. So we should be good. And that is section 2.1. We practiced on translating and then the beginning of graphing inequality statements. Next section, 2.2, was on solving one-step inequalities using addition and subtraction and then graphing it. So these are one step using addition and subtraction. So the top of your second section, 2.2, you would write 2.2, solve inequalities using addition and subtraction. That's what you would title it, so that if you see any question on the test about solving inequalities with addition and subtraction, you've got two examples to go off of. If you look in the back of the chapter 2 in the book, you'll see an example for section 2.2. It looks just like this. If you'd like to look at it when you're studying, I highly encourage it. Otherwise, here are the two examples I'm going to talk through that you should be writing down as well. So can you solve and graph? I have x minus 4 is greater than negative 2. How do I solve it? I add 4 to each side. That's what undoes subtraction. I then get x has to be greater than negative 2 plus 4 is 2. There's my answer algebraically. Now I'm going to graph it. So I draw in a number line. 2 is my key point. Circle, I want all the values that are greater than 2. If I pick any value bigger than 2, it should make a true statement. Let's check. Here's a number bigger than 2. How about, I don't know, 7? If I put 7 in here, 7 minus 4, is that greater than negative 2? Well, 7 minus 4 is 3, and 3 is definitely greater than or to the right of negative 2. So this checks out. So 7 works because it's in a solution set. Second one, I have negative 5 is less than or equal to x plus 7. How do I solve this? I subtract 7 from each side. I then get negative 5 minus 7 is negative 12 is less than or equal to x. You'll see here I don't go changing this sign because I subtracted 7. It's only if you multiply or divide by a negative. We'll see that in the next section. So here I have negative 12 is less than or equal to x. X represents all my answers. When I write an inequality, I want my variable to come first so that it will match my graph. If negative 12 is smaller than x, that means if I write my x first, x has to be bigger than negative 12. It's like saying Sally is shorter than George, so George has to be taller than Sally. There's my answer. X has to be greater than negative 12. Now I graph it. Put a dash down at negative 12, circle around. I want all the values that are greater than or equal to negative 12. If I pick any value greater than or equal to negative 12, it should be true. What's an easy one to check? 0. 0 is all the way over here. It should work. If I put 0 in here, 0 plus 7 is 7. I get negative 5 is less than or equal to 7. Is that a true statement? It is a true statement, so it works out. So it checks out. I should put the check actually like down here. So we're good. That's 2.2. 2.3 was on solving inequalities using multiplication or division. So 2.3, one-step inequalities using multiplication division. Almost the exact same thing we wrote here. 2.3, solve inequalities using multiplication or division is what you should put at the top. Then we're going to put two examples. One example using multiplication, one example using division. After you've titled it, you should write this at the top of the section to remind yourself. You should write, if you multiply or divide by a negative, you need to flip the direction, which is the sign, of your inequality. You need to switch it. We talked about why this was true. There is a question on the quiz that asked about this. Example, if I have a statement 5 is less than 10, if I multiply both sides by a negative 1, I end up with negative 5 and a negative 10. Negative 5 is now greater than negative 10. If I didn't switch the sign, the statement would no longer be true. Because negatives switch signs of numbers, they also have to switch signs of inequalities because inequalities have a directionality to them. So two example problems. x divided by -4 is less than 2. How do I undo dividing by -4? I multiply by -4. Now this -4 is going to cancel the bottom -4. By cancel, I mean make the number 1, because -4 divided by -4 is 1. So this leaves me with 1x. 2 times -4 is -8. In order for this statement to still be true when I multiply by a negative, my sign needs to change direction, so it now needs to be greater than. I need to pick a number greater than -8 in order for this to be true. So I put a dash down, -8, circle around it. I want all the values that are greater to the right of -8. What's a really easy one to check? 0. If 0 is in there, I think 0 is easy to check. Put 0 in there. 0 divided by -4, is that less than 2? It is, because 0 divided by -4 is 0, and 0 is less than 2, so it checks out. It's a true statement. Second one, 1.5 times x is less than or equal to 6. How do I solve? Divide both sides by 1.5. Do I need to flip the sign here? No, because I'm dividing by a positive. Positives don't change signs of numbers, so they won't change signs of inequalities either. X has to be greater than or equal to, this is going to make the number 4. I need to be bigger than or equal to 4. So 4 is my key point, circle around 4, and then I shade to the right of 4. If I pick any number bigger than 4, it should work out. What's an easy one to check? I don't check 5. Put 5 in there. 1.5 times 5, is that greater than or equal to 6? It is, because that's 7.5. And 7.5, it's bigger than or equal to 6 because it's bigger than. So it works. And those are the 3 sections I believe that I am going to guide you through. The last 2 are going to be on you. So there's 2 more learning targets. 2.4 is on solving multi-step inequalities. I would make sure at the very top of that section to write what the 3 steps are for solving any multi-step inequality. It's the same for any multi-step equation. Simplify, same side, solve. Still be aware about multiplying or dividing by a negative. That will still change your sign even if it's a multi-step. Then in 2.5, solve and graph compound inequalities. That was your and or inequalities. I don't have the quizzes to pass back to you, so you can't use the quizzes as examples. So where can you pull your examples from? I would then say, because I haven't got the quizzes back to you, there's 3. You could use the end of chapter review in the book. Looks like it'd be page 94. If it's not, just know it's in the back of chapter 2. I'm not 100% certain on that page number. Actually, let me check it right now. Let's see if that's true, if it's page 94. Yep, page 94 is right. That's where they start. If you're looking for 2.4, 2.4 is on page 95, actually. 94 is where 2.1 and 2 are. So 95 and 96 are the 2 pages that have 2.4 and 2.5. So you can pull them from there. I actually think the best place to get them would be Note Packet. I'd use Note Packet or homework. Either one of those would be excellent places to get examples from. You need to get 2 examples down for each of those sections. And then once you have those 5 sections filled in, you are done for the day, but you need to show our guest teacher that you filled in the review sheet before you check in your calculator and earn your paycheck for the day. So just like if I was here, show our guest teacher that you completed the work. And then the remaining part of the period, I just ask that you can use it as a study hall. If you have work for another class, feel free to use it. If you have makeup work for this class, maybe get that done. But just respect people who are still using the time appropriately. So thank you very much. Have a good day, and I'll see you when I get back.